we are going to use this equation to fill in the table. Given this equation, we're going to figure out the values of y. We're going to choose values for x, okay? So if x is 0, we're going to go all the way up to 5. 3, 4, 5. If x is 0, we can do the first one together, okay? We can rewrite this equation. We don't have to put that plus 0. Y equals negative 1x squared plus 5x. If x is 0, so I'm replacing x with the number 0. Well, what's negative 1 times 0?
0.
Plus 5 times 0?
0.
So the first point is 0, 0, like we predicted. Because we noticed that C was 0, and we just learned that C represents the y-intercept. Okay, do the next one, and then you guys will fill it in on your own. If x is 1, so now wherever I see an x, I'm going to replace it with the number 1 to figure out y. Y equals negative 1x squared plus 5. Always do your exponents first. 1 times 1.
1.
So y equals negative 1 times 1 plus, what's 5 times 1?
5.
Negative
So
1 times positive 1. Negative 1 plus 5.
4.
So we know the next point is going to be located at 1, 4. You guys fill in the rest, okay? Okay, no. Now we're going to look at, once we fill in the table, using this equation is what represents our graph, and we can use it to fill in the table. We want to find the first differences, just to see if this is linear. 4 take away 0.
4 take 0. 4, sorry.
6 take away 4. 4 take away 6.
Guys, we have to go back to recap. So,
Negative 2. 0 take away 4.
negative 4.
Okay, now let's find the second differences, okay?
2 take away 4.
2 take away 4.
Negative 2.
0 take away 2.
Negative 2.
Negative 2 take away nothing.
Negative 2.
Negative 4 take away negative 2.
Positive 2.
Negative
Oh,
2.
that's trying to trick me. It's trying to trick me.
Okay.
It's trying to trick me.
So as we can see, the first differences are not the same, so we automatically know it can't be linear. If the second differences are the same, which they are, we know it's going to be quadratic. If the second differences were not the same, is it linear or quadratic, or neither? Neither, okay? So we know this is going to be quadratic. And looking at our equation and looking at the second differences, how will this parabola open?
Guys, now
It's going to
time graph
open
it.
down. Okay, yes, we're going to graph it now. So we're going to use, these are our coordinates, okay? First point is located at 0, 0, then 1, 4, 2, 6, 3, 6, 4, 4, and 5, 0. We have 6 points to plot on the graph. Okay, so as we can see from our graph, the parabola opens down like we predicted, and as I told you earlier, a parabola is a U-shaped curve that's symmetrical. So every parabola has, we can draw an imaginary line of symmetry. I want you to draw
Every computer has.
a line of symmetry, a line that would divide both parts into 2 equal parts. Or sorry, the whole thing into 2 equal parts. Where would you draw your line of symmetry? It has to divide my parabola in half, so it'd be in between. Exactly. Oops. Sorry. Like right here. Okay, I'm going to do it in yellow.
Also
This
2.5.
This divides my symmetry in half equally.
So 2.5.
When you're asked to find the axis of symmetry, you're trying to figure out what is the x value of the axis of symmetry. Because if you look here, the axis of symmetry will go through the x-axis, right? This is my x-axis. I want to know what x equals. Well, you can pick any single point on this parabola that has the same y value. So for example, where's this point located? What's the y value of these 2 points?
Which one?
This one and this one. What's the y value?
Miss, it's not even writing, so you should like bigger.
Let's look at this point here and this point here. What's the coordinate of this point?
4,
1,
and 4.
4, and this one is
4,
4. Both of these have the same y value, right? So you know that they're in the same, I guess you could say, row.
Yeah.
Okay? I know that halfway between this point and this point will be where my line of symmetry hits. So it's actually the midpoint.
Whoa,
Okay?
We're back to midpoint again.
We're back to midpoint. It's actually the midpoint.
x2, x1 plus x2.
Find the midpoint using our x coordinates. So what's halfway between 1 and 4? Halfway, we're going to divide by 2. 1 plus 4? 5 divided by 2 equals...
2.5. Exactly.
Did this hit at 2.5?
Yes.
Okay, let's try the other one. Let's try this one. This point is at 2, 6, and 3, 6, right? 2 plus 3, so I'm adding my x
5.
divided by 2,
2.5.
2.5.
Oh my gosh, it's the same thing.
My axis of symmetry is x equals 2.5. It's an equation. It's x equals 2.5. Anywhere
That is scary.
on this parabola, the line of symmetry passes through any single point will be 2.5 something, right? Anywhere, 2.5 something, 2.5 something. The axis of symmetry is 2.5. That's halfway between any single point on this parabola. Vertex is located where the parabola changes direction. So in this case, we can look at the graph, and I know it's going to be somewhere around here, right? This is where the parabola changes direction. What do you notice about the axis of symmetry and the vertex? What do they have in common? Anyone notice anything? So the axis of symmetry, Jover and Eichel, the axis of symmetry passes through the vertex. So I know that the vertex is located at 2.5 something. It's really hard to tell on this graph because it's hard to see where I drew it. So we're actually going to calculate where the vertex is located. I know that if x is 2.5, that's where my vertex is located. We're going to use the equation to find y. When x is equal to 2.5, because I know that when x equals 2.5, my y value will be the vertex. That's the only point where it touches the parabola. So let's replace x with 2.5. Okay, let's replace x, 1 second. So I have y equals negative 1, 2.5 squared, plus 5 times 2.5. Exponents first. What's 2.5 times 2.5, not plus? 2.5 times 2.5. Okay, it's 6.25, so it's going to be negative 1 times 6.25 plus, what's 5 times 2.5? 12.5. Y equals a negative times a positive is a negative. And I have negative 6.25 plus 12.5 is equal to positive 6.25. Therefore, I know that the vertex will be located at, what's the coordinate of the vertex? What was the x value of the vertex? Let's check our graph to see if that looks reasonable. Yes, it looks like it's approximately at 6.25. 2.5, 6.25. It's accurate. It's reasonable. Okay, now we found the vertex. Shh. Now I want you to tell me what is the maximum value of this parabola. What do you think maximum value means? The greatest value that this parabola has. Well, this parabola starts at 0. It goes all the way up to here, and then it comes back down to 0. What's the greatest value that it can have?
2.5.
Right, good. 6.25. Okay, so when you're asked to talk about the maximum value, it's actually what part of the vertex? The y value. The greatest value will always be the y value of the vertex because the parabola won't go past that point. Okay?
Made with Doodlecast Pro.